Hi guys, welcome to my channel. Today we're going to be looking at a question from the Oxford MAT. The MAT stands for the Mathematics Admission Test, and applicants for maths or computer science at the University of Oxford and a few other universities must sit it. So let's get straight into it. For a real number x, we denote by this the largest integer less than or equal to x. Let n be a natural number. The integral from n to 0 of the floor of 2 to the x with respect to x equals what? So the first thing that we're going to do is we're going to graph the function y equals the floor of 2 to the x for a few values of x. When x is 0, y is going to be the floor of 2 to the 0, which is 1. When x is 1, y is going to be the floor of 2 to the 1, which is 2. And when x is 2, y is the floor of 2 squared, which is going to be 4. So what we can notice is that between x is 1 and x is 2, we're missing the value 3. So that's going to occur when x is equal to the log of 3 base 2. And another thing to notice is that if x is between 0 and 1, then y is going to be equal to 1. And essentially the graph's going to look a little bit like this. So at x is 0, we're going to be at 1. And then when x reaches 1, we jump up to 2 until x reaches log 3, at which point the graph jumps up to 3 until x reaches 2, and then it jumps up to 4. And it continues in this way. And to evaluate the integral, we can consider these rectangles here. So the width of the first rectangle is going to be 1 minus 0, but it's going to be more convenient to write it as log 2 minus log 1, and then the height of it is 1, and then the width of the second rectangle is going to be log 3 minus 1, but we're going to write it as log 3 minus log 2, and the height is 2, followed by the third rectangle having width log 4 minus log 3 with a height of 3. And with a straightforward inductive argument, we can see that this is going to go up to log 2 to the n minus log 2 to the n minus 1, the height of 2 to the n minus 1. But one thing we're going to notice is that when we evaluate the sum, most of these terms are going to disappear. For example, if we expand this term and this term, we'll get log 2 minus 2 log 2, which is going to be equal to negative log 2. Similarly, if we then expand this third term, we'll get 2 copies of log 3 minus 3 log 3, which is going to give us negative log 3. And in this manner, we can see that our sum is going to evaluate to negative log 1 minus log 2 minus log 3, all the way to minus log of 2 to the n minus 1. But one term is not going to cancel out, and that's going to be this term here. So when we multiply it with this bracket, we're going to be left with plus 2 to the n minus 1 times log of 2 to the n. But we can rewrite the final term by expanding it. So it's going to be minus log of 2 to the n plus 2 to the n times log of 2 to the n. Now let's first consider this sum. So we'll factor out a factor of minus 1. And then let's also consider our remaining term. Well, this bit inside the bracket is just n, so it's going to be n times 2 to the n. And if we consider the sum inside our brackets, since we know that log of a plus log of b is log of ab, this is going to evaluate to 1 times 2 times 3, all the way to 2 to the n plus n times 2 to the n. And the bit inside the log, that's just 2 to the n factorial. So we can rewrite this as n times 2 to the n minus log of 2 to the n factorial. And this is going to be our final answer, giving us option B. So how did you find this question? Let me know in the comments below. If you enjoyed, please like and subscribe and share it to a friend to see if they can solve it too.